All right. So what you start out with here is what we're going to put in our cabin. Okay, these are different models of, let's see, Whirlpool refrigerator, a TV. You have your electric lights, your light bulbs. You have your microwave, washing machine, and then phantom load. So phantom load is like your power, your charger for your cell phone that's plugged in, that basically has this small load that's pulling power all the time. It's waste, really. Or maybe it's your television that stays plugged in all the time, but it's kind of on this standby or something. So that's phantom load. So we'll stick with this. And we have some other assumptions. So we have DOD, that's depth of discharge. Depth of discharge is how much you're discharging your battery. Okay, so it would be like your battery is kind of like a gas tank. Okay, so it has a capacity just like your gas tank. Gas tanks are in gallons, batteries are in amp hours. Okay, so depth of discharge means that if you start with 100 amp hours, your depth, and you discharge down to, let's say, 30 amp hours. You have 30 amp hours left. You have discharged 70 amp hours. Depth of discharge is the 70 amp hours, so it's how much you've removed from your battery bank. Now, on the other hand, state of charge, SOC, is how much you have left. Okay, so state of charge would be the 30 amp hours you have left. So those two are complementary figures. So depth of discharge is how much charge you've removed from the battery. State of charge is how much there is left. So what it's saying here is that your depth of discharge shouldn't be more than 70%, which means that you shouldn't discharge more than to 30% state of charge. Okay. You have 48 volt bank. Conversion efficiency of the inverter and other components is 85%. We'll use that later. And then we're going to start with a fully charged battery bank. You don't know what Pucher's law is, so forget about that. Doesn't matter for what we're doing. It's important if we were really diving into what batteries, but we're going to just skip that. Okay? So, all right. So the first question is, what is the battery bank size needed to meet the criteria? So battery bank size to meet the criteria. So all of these things, we have to figure out how we're going to, what size battery bank we need for all of these things to be powered. So that's what I'm going to show you. So what I need, let's see here. Got to go to one of my thousands of tabs open and go back here. So where it says week 6, we're going to go ahead and, no, sorry. Part 1, system development, right here. Go ahead and download Energy Audit Spreadsheet. So what we are going to do is we're doing this energy audit. So if you were going to design a system for a customer, the first thing you're going to talk to them about is what do they want to put in their house. Now, new construction will likely have more efficient appliances, right? Because you can buy more efficient appliances now. So that would be something you could suggest to them. If you're doing a retrofit where you already have appliances in there, they may not be as efficient, so that might be an issue. So when you ask them, they're going to give you that list of appliances like we have in our assignment. And you can use this tool. So this is your audit spreadsheet. So first one on there, what is that? What's the first one on there? does it say? I can't, I didn't want to flip back.
Whirlpool W831F1.
Okay, it's the fridge, Whirlpool fridge. Cool. Pool fridge. Okay, we have one. All right, and then operation hours per day. All the time, 24 hours a day. Standby means that it's not pulling full power. So like I said, standby would be, your computer that doesn't turn all the way off. There's no standby for a fridge. It is always on. So you could say 0 hours a day for standby. We don't have to, let's see. So now what I need you guys to do is I need you to find that model and I need you to tell me either the kilowatt hours per year it pulls or the watts on, either or, because sometimes those specs are given differently or given at different times. So try and find that on the internet.
What? 36.5. 36.5.
36.5 watts on?
No, never mind. 320 kilowatt hours a year.
320 kilowatt hours per year. Okay. Cool. So we need to take that and we need to change that to watt hours per day. So who wants to do that conversion?
Watt hours per day, but it's in here. It's asking for kilowatt hours per year.
Yep. You put kilowatt hours per year, then we have to convert it to watt hours per day.
Oh, okay. $877.
877? 876. Okay, yeah, 877. All right. So what do we have here? So this column right here where it says watt hours, you can see up at the top, I have watt hours per day times 3. The 3 comes from the 3 days of autonomy, meaning we want to have our bank power our appliances for 3 days without having to tap into our generator. Okay. So that's where the 3 comes from. So that changes it. So you go watt hours per day times 3 days is watt hours. So that is 2,630. And then we have a 48 volt bank. So we're going to divide our watt hours, watts meaning power, by 48 volts, which is going to give us amp hours. Okay, so you got amp hours. So remember, amp hours is how we measure the size of a battery. So you could stop right there and say, okay, cool, that's the Whirlpool fridge contribution as far as load. But the other thing is, remember that we don't want to discharge our battery bank more than 70% depth of discharge or 30% state of charge. So that means that what we're going to do is we're going to oversize our bank by that 30%. Okay, so that means we're going to multiply column K, which is our amp hours, by 1.3 to increase. Yeah.
Wouldn't you need to multiply it by a bit more, because since 70 is now 100%, you have to base the 30 more percent based on 70, not 100?
No. So it's
because if the total amp hours is 54, And that total is 70% of what we want.
Okay.
Then we have to divide by 70 multiplied by 100
Divide by 70, multiply by 100.
to get to 100%.
Well, Dylan, you may have got me here. Let me think about this. All right. You got the idea. I'm glad. But you also may have stumped me. All right. So if we need to have 30% left, so we've got, let's see.
I have the number.
Yeah. Did you divide by 70?
Yeah. It'd be
0.7. Sorry? No, what did you say?
You would need to multiply it by 1.43%
1.43.
instead of 1.3.
All right, let's see here.
Or divide by 70.
I was gonna say, oops, wrong one. Divide by 70. You are exactly right. All right, divide by 70, 0.7. And then we need to do the same thing here. We need to divide by 0.85. So, oops, sorry, thanks. There we go, divide. Okay, cool. So then we need to make sure that we apply this to every row. Okay. Yeah, so what I'm doing right here is, so for L, for the column L, I changed the formula to K2 divided by 0.7. Okay, and then the next one for column M, divided it by 0.85. No, you shouldn't apologize. You're right. So then we need to make sure that we apply this to every row. Okay, because the next thing you guys need to do is do this for the other things on that sheet. Okay, so you need to go through and find the Samsung TV, the LEDs, your LG, and then your washing machine, and then it gives you the phantom load already.
So quick question.
Yeah.
What is the extra thing that's already on the sheet?
Oh, delete that. It's not important. It just got left over, I think. Okay. Yeah, delete the extra thing. This one. And we'll see what we've got here.
So is that 15 lamps? Is that what
15 lights. What's that gonna do?
lights do not draw power for anything. Right.
So it says 2 hours per day for the lights.
I was asking for the standby. They don't have.
Oh yeah, no, there's no standby. Good question. So there's no standby for the lights. And then what else are we looking at here? You got standby for washing machine, and for the microwave. And You probably are gonna have standby for the TV as well.
Doesn't it say to assume uniform energy usage of the TV?
It says for, oh yeah, because that spec will give you the per year instead of hours per day. Because I've looked at these specs already.
Is that supposed to be 20 watts per day per year? Miscellaneous?
That is supposed to be per, let me roll up here. Total 20 watts per day. Wait, before you do that, let me check. 20 watts.
And do we need to use the watt surge column at all?
You shouldn't have any surge. No, I don't think so. So good question. So for surge, surge would be something like if you start up like a table saw, yeah, like a motor or something, then that's where your power peaks for a certain amount of time, like could be seconds. And so you have to account for that when you're sizing your inverter. But I don't think we have anything like that. So we should be fine.
When they say one, it's giving us one, right?
Huh? Oh, sorry.
Oh, sorry.
I was gonna ask about that.
What were you asking?
The light bulbs give wattage as a unit.
Uh-huh.
That's watt hours, right?
No.
Oh. Okay.
No, watt hours is a different, that's watts times hours versus just watts.
Okay. You say uniform usage for the TV, does that mean it's on all the time?
No, so the spec, have you pulled up the spec?